Okay, almost up. There's Alex and that's Michelle. Is that Kaylin and Daniela? Do I see Kaylin and Daniela? There's Kaylin. Okay, no Daniela at the beginning. All right, well, we'll start there. Good morning, everybody. Welcome to pre-calculus in the middle of trigonometry. I say that's not true. We're still at the beginning. Pretty much the whole semester is going to be trigonometry. So we're in the thick of it. We are not at that halfway point, in case you were getting hopeful there. There's Danielle. All right, excellent. Everyone's here. But we're starting off with the simple stuff. And today we're dealing with right triangle trig, which is going to expand right from that unit circle that we used last week. So the more you have that in your brain, the faster and easier all of this is going to be. All right, so again, from that unit circle, in fact, I should have just brought one on the page here. Let me grab another color, right? We had our unit circle, our center point, and we can define any point on that circle based on its x, y coordinates, as well as a distance from the center, the unit circle. We set that distance to always be 1, and then an angle up from the positive x-axis. This is always positive x, right? This would be your positive y-axis, and that's our standard position for an angle, is measured from the positive x-axis and rotating outward from there. In fact, this is where polar coordinates comes from, is just based on, instead of defining horizontal, vertical, they define angle and distance, okay, as your two variables there. But notice that if I draw in my horizontal and vertical locations from anywhere on the circle, I'm left with a triangle. And since horizontal and vertical are always perfectly perpendicular to each other, it is a right triangle, and thus we develop the right triangle trig. This is why all of the trig functions are defined based on a ratio of sides of the right triangle, because you can always create a right triangle. And then the functions change as that ratio adjusts. As you change your angle and you notice the changing relationship between the size of your movie screen and the distance from you to the screen. So real quick, I think we all remember our SOHCAHTOA, right? Sine is, anybody? Shout out. Give me it in chat. Everyone should know this. In a right triangle, sine is defined as what over what? Ivan's got it. Alex has got it. Yeah, all right. The opposite over the hypotenuse, right? Which in this case becomes the opposite side is my y coordinate. The hypotenuse, remember this is the unit circle, it will always be 1. So it's y over 1, or simplifies just to y. Your sine of an angle will always give you the y coordinate of its position on the unit circle. Does that make sense? How that definition then becomes a useful tool, Be like, hey, this is about that far up. Okay, but like literally how far up is it in a distance measure? Oh, okay, input sine, right? If you want height of anything, use sine. Okay. Cosine then is defined as, chat? Oh, that was fast. Danielle, you like had that pre-typed and you were just waiting for the question. Say it again. Say it, Mr. Apple, and I will smash that enter button. Very good. Ruby's got it. Adjacent over hypotenuse. I'm going to try to color code these here. The adjacent side over hypotenuse, which results in giving you the x coordinate every time. That's pretty handy, right? So sine gives you the height, cosine gives you horizontal distance. I don't want to say distance because that's too generic. So if we can remember, it's always the horizontal, right? How far away from your face is the movie screen that you've set up in your dome here. And then tangent is defined as there we go. Thank you. Perla's got it now. Opposite, which I did in red here, over adjacent, which now gives you a ratio of y over x. Now that one's a little bit different, right? Because this one doesn't tell you an exact measurement. It's still a ratio of measurements. But this tells you how square something is. You could think of it that way, right? Think of it as, right, if you were measuring a person, right? Are they a tall, thin person, or a short, wide person, right? Someone who's got like long arm span, right, but doesn't have very long legs. So it determines how squarish or rectangular, right? Tall, thin, short, wide is the tangent there. And then that's only half of them. Because we have these three things, opposite side, adjacent side, and the hypotenuse side, and we want to make every possible combination. So somebody else came along and said, okay, sine, cosine, tangent, those sound great. But what if we had new words that sound even more ridiculous to define the other three? Can anyone tell me what cosecant is? Abbreviated CSC. Oh, we don't know that one. Yeah, see, these just get less love. I don't know why. They're slightly less useful, and thus they get ignored far too often, and then people don't know it. Yeah, there's a good way. Ivan, I like the way you've said that. It's 1 over, or opposite of sine. Yeah, so there is a reason I've lined them up here. Okay? So cosecant is, again, as a definition of right triangle sides, it would be the opposite of the sine. So we're going to put the hypotenuse on top and the opposite on the bottom, which, yes, has the result of giving us 1 over sine of theta. Or you could think of it as 1 over y. It's the reciprocal of the height. Is that as useful as a straight-up application question? Not as much. Not as immediately obvious where you would want that measurement. But it's still there. You can go back to the Better Explained article. He does expand the dome analogy to make use of these, and it has to do with going outside the dome. Instead of hanging the movie screen inside the dome, what if you wanted it outside the dome, right? How tall could you make it, and versus your neighbor's fence, and looking at it from the top of the dome versus the side of the dome, incorporates these ratios there. But the simplest approach is to remember that these are the reciprocals of our classic ones. So cosecant is 1 over sine, secant is 1 over cosine. How you're supposed to remember that, it's really unfortunate that the co doesn't go with the other co, right? It'd be really nice if the cosecant was the reciprocal of the cosine, the co to the co, but it's not. So you're just going to have to remember that it's not as convenient a mnemonic as you might like. So just to fill this out here real quick, let's finish. This is adjacent on the bottom, hypotenuse up top. It is 1 over cosine, or 1 over x. And the cotangent, though, cotangent totally works. That's our reciprocal there. 1 over tangent. And we'll kind of touch a little bit on why that is. Why does cotangent get to be opposite of tangent, but cosecant isn't opposite of cosine? The co means something different, okay? And we'll touch on that at the end. So with those ratios in mind, and borrowing from your unit circle, can you find all 6 trig values in exact form for, let's just start with good old 30 degrees. Ready, go. Sine of 30, cosine of 30, tangent 30. In exact form, okay? No long repeating decimals. Send it over in chat. This is the easiest one. Type it up, comma, in this order, right? Sine, cosine, tangent, cosecant, secant, cotangent. Give me a list of 6 numbers separated with a comma in chat. 6 trig values for 30 degrees. This should be the easiest one. Pi over 6 is an angle. That's the radian equivalent of 30 degrees. It's not what I'm asking for. I want the trig function for each one. I want sine of 30 degrees. We'll go one at a time, in order. Sine of 30 degrees, everybody. How much? Oh no. Oh, there, Ruby, thank you. Ruby's got it. Why is this not an immediate response? Okay, we're going to have to do this. You have to remember this. Kaylin's going there. Sine of 30 degrees is 1/2. Turn on your microphone. Repeat after me. Sine of 30 degrees is 1/2. You've got to hear it. Say it out loud. Sine of 30 degrees is 1/2. Remember that guy. Commit this to memory. That is the most commonly used angle, the most commonly used trig function called for. Absolutely. Sine of 30 degrees is 1/2. And if you know the relationships, how these relate to one another, this you can get away with just about all of them. The 45 degrees, guys, will throw you off. You need that number as well. Right. Sine of 30 degrees is 1/2. So cosine of 30 degrees is, look at your unit circle. Where do you have 1/2? Remember I told you you only need a few values. You need root 2 over 2, 1/2, root 3 over 2. Root 2 over 2, that's that matching 2's. That's that symmetry one. Ooh, the symmetry one goes right through the middle of the quadrant. This is not it. 30 degrees. It's not the middle of the quadrant. Scratch that. Use the other number. It must be square root 3 over 2. Process of elimination. Because I know sine of 30 degrees is 1/2. So cosine has to be the other one. Here. Tangent. Tangent is the ratio of the two. So if you divide opposite over adjacent, sine over cosine, y over x, 1/2 divided by root 3 over 2, you've effectively canceled out the divide by 2. This says divide by 2 and then divide by, divide by 2. Right? Fraction rules. Multiply by the reciprocal. Okay, so it's 1 over root 3. Or rationalize the denominator, root 3 over 3. Now, once you've got those three, the rest are easy because they're just the opposite, the reciprocal. Should specify reciprocal, don't say opposite. Mathematically, opposite usually implies the negative. So please specify the reciprocal of. So then cosecant of 30 degrees, or, spoiler alert, cosecant of pi over 6. Is that going to throw you off too bad? Pi over 6 radians is 30 degrees. Oh, it's the same thing. So it's reciprocal of sine. 1 divided by 1/2. Back to 2. Kaylin with all the answers there. Thank you very much. So secant would be, flip that around, 2 divided by root 3. Or if you want to rationalize the denominator, multiply by root 3 over 3. Root 3 over root 3, sorry. Yep. And then cotangent pi over 6. Oh, that should be a 30 degrees up there. Gives you reciprocal of that, which is just square root of 3. Hey, any questions on how we got those values? This is why we're still practicing these. They need to come lickety-split. This should be the simple stuff, all right? Because when you get to calculus and you start needing to do more complex things with these quantities and these functions, you don't want this part of just the simple evaluation of common angles to slow you down. Make this automatic. Save your brain power for the actual hard stuff. Okay? So all of these first quadrant unit circle numbers, you need to be able to do quick and easy. Whether that's because you've memorized it or because you memorized part of it and you remember the relationship and you can quickly get to the other one, or you can quickly create your unit circle or part of a unit circle and just read it off of there. I don't care how you do it. Just be able to do it quickly by hand without relying on, making sure your calculator is the correct format so it doesn't give you the decimal, because very few calculators by default will read out square root 3 over 2. Okay? They will give you the decimal approximation. You don't want that. In calculus, fractions are your friend, okay? Because more simplification things happen from fractions. All right, are we good with that? We can go on. Don't have a lot of time because we got to fit our reading quizzes in here, and this is really where it'll push you. All right. So as promised, why are some get cos and some don't? What's the deal here? What does it actually mean to be the cosine with the sine? The co-functions come from the complements in the triangle, right? Recall from geometry, an angle is complementary to another angle if they add up to 90 degrees, right? A right triangle, all three angles in any triangle add to 180. In the right triangle, one of them is already 90, so you take 90 out. The total left, these two must add up to 90. Therefore, they are by definition complementary. So alpha here is equal to 90 degrees minus theta there. No matter what theta actually is, alpha will always be its complement. And so the really cool thing about this, go ahead and try this. Okay, use your calculator. Give me a sine of 20 degrees. What is it? I don't have mine handy. That's not one on the unit circle. I will accept a decimal. Give me like 3 places or more. I can round off of chat. Thank you, Ruby. 0.342. Now, somebody, who have I not heard from? Anybody? Call on someone specific. Now I'm going to need the cosine of alpha. If theta here is 20 degrees, alpha is 90 minus theta, so 90 minus 20 gives us 70. So what is the cosine of 70 degrees? What about, Natalie, have I heard from you? No. Either one, that's right. We got 2 Natalies. Natalie A, Natalie Z. What is the cosine of 70 degrees? I think even phone calculators have the trig function, do they? That one I could probably get out. There, I'll race you. See who's faster. Not there yet. Oh yeah, see? We got right there. Sine, cosine, tangent. Can even do it on your phone. Thank you, Ruby. I'm asking one of the Natalies. Both of them, actually. Figure out how, let's see, I would type in the number and then hit, nope, it actually types it out properly. Okay, I did not expect that. Okay, so we hit cosine, then 70. There we go, thank you. There we go, you get the same thing, 0.342. All right. That's why is that symbol an X? That's an alpha. Right there. Greek letter alpha. Right? Doesn't it kind of look like an A or the fancy A? Right? It's similar. Yep. Greek letter alpha. Back at the beginning of the year, I gave you that list of numbers worth knowing. I should tack onto that. Letters worth knowing. Learn your Greek alphabet. The sooner you learn your Greek alphabet, the That's a really good point. Yes, learn your Greek alphabet over the summer. Okay, that's my challenge for you. Over the summer, learn the Greek alphabet. So when you do get to college and your calculus professor is writing all these Greek letters on the board, right? Because they will be throwing these alphas and betas and thetas and gammas, and you'll be like, what the heck is that symbol? Okay, and it'll be confusing because they'll speak with a really heavy accent, and because we needed more letters. Why is it in Greek? Because we ran out of letters? I don't know. They don't. That would be a really interesting historical math question for another day. Why we use Greek letters. But start to learn them so you're not thrown off there. Anyways, so that's cofunctions and complements, right? Sine and cosine, secant and the cosecant. So if you find the secant of an angle, you can find the cosecant of the complement to that angle, and you will get the same thing. So there you go. Cofunctions are just the functions of the complements of the angle. And when we get to the graphs, you will see that they look exactly the same except shifted over. Kind of cool. All right, one last detail here. Of course, we got to do this. Right triangle trig, you can use it to measure stuff that you couldn't otherwise easily measure, right? So, solution to, hey, I can't reach this with my tape measure. How am I going to see how long this is? Or maybe you didn't bring your, what's the thing for measuring the angle of the sun? Astrolabe? Some sextant, one of those nautical navigational tools. Anyways, right? You don't have that with you because you live in the modern era. Why would you have that? Right? So, the solution, draw a triangle. Right? Use trig to find the unknown values in the right triangle. Right? Algebra ensues, profit. Okay? Easy peasy. So, here we go. Here's a quick example for you. A 50-foot tall tree. We already know. We asked the arborist around there, and he told us that this tree, yes, it's orange, is 50 feet. Okay. It's currently casting a 40-foot shadow. Okay. So we can create our triangle here. Wait. Here. There we go. And it should go the other way, right? It's taller than it is wide. So is that better? Doesn't matter. 50 there, 40 here. The tree is growing perpendicularly, so it's at a right angle. It's a right triangle. Find the angle of elevation of the sun, right? Because it's the sun up here, right, shining down, that creates the shadow in the first place. Now, we have two angles in our triangle. Which one, theta or alpha, is our angle of elevation? How do you know? Alpha? Question mark? Are you just guessing? Angle of elevation or an angle of depression is always in comparison to the horizon. Okay? You look off at the horizon at the perfect sunset. You say, that is a 0 degree angle of elevation, right? Imagine sun setting over the ocean. You just watch. Beautiful image. That orange pink dot on the flat blue line. Okay? Horizontal. Now, sunrise, as the sun rises up and lifts, elevates above the horizon, that is your angle of elevation as it goes up and up and up, over and over and over, right? And up we go. So it's always compared to the horizontal. An angle of depression, if you were flying in a plane and you look down at the cities and the farmland and the fields, right? And, oh, look, a little cow, and I can see my house from here, right? Angle of depression is always from the horizontal. So you've got to find which one of these is from the horizontal line. That would be theta. Okay? So when we say angle of elevation, we are looking for, in this case, theta. This guy down here, which means we are set up. We have which sides of our triangle compared to this angle. We have the adjacent side. And over here we have the opposite side. So which one, opposite and adjacent? That's going to be one of these gentlemen down here, the tan or the cotan. You can use either one to solve for theta, right? Let's use cotangent. I bet you weren't expecting that. Bet you weren't expecting cotangent. We'll use it. The cotangent of theta will be equal to adjacent over opposite. So in this case, 40 over 50. So that's 4/5. We want to find theta. So we have to use the inverse function on your calculator, right? Second, right? Inverse. So I want inverse cotangent of 4/5. Mr. Eppa, I don't have a cotangent button on my calculator, let alone an inverse cotangent button. What are you doing to me? All right, fine. So use tangent then. Cotangent is just 1 over tangent. So 1 over tangent equals 4/5. Okay, so tangent, you're going to solve the fraction, you're going to get 5 over 4 anyways. Okay? Can't reciprocal this thing out here. I can reciprocal that. Look at that. Okay, so theta now is inverse tan of 5 over 4. Type that in your calculator. What do you end up with? Give me to the nearest 1/10 of a degree. Thinking that. See, now I got to double check. Does even the phone calculator, does it have inverse? It'd be amazing if it has inverse. Oh, it totally does. There's an inverse button. Look at this. Look at this. Look, I've got inverse button. So I press that button, and now all of a sudden they turn into inverse functions. Oh, we can totally do this. Right here on, at least this is the Android one. I'm sure Apple has reasonable equivalent. So we go 5 divided by, no. Type it out first. Inverse tan 5 divided 4. All right. There you go. See, it even works on the phone. So we get an angle of 51.3 degrees. Does that make sense? Does that sound like a good angle to you? Double check that. The tree is 50 feet high. The shadow is 40 feet long. The tree is taller than its shadow, okay? But more height, right? Which is why I spun my triangle around to look a little bit more proportional, okay? So I need to get an angle that is more than 45, right? 45 is that halfway point. It's equally square. Perfectly square would be 45 degrees, right? I got a little more than 45. So remember, the tan shows you how square. So this is telling me that my full rectangle, if I complete the rectangle of that triangle, I get a tall, skinny rectangle. Not that tall and skinny, but a little taller, skinnier than a perfect square. That's what that number represents. All right, final questions on right triangle trig. Ivan, you got 51.3 as well? Okay, good. Glad somebody double checked, just in case my calculator was off. No questions? All right, then take out your notes. It's time for quizzes. We've got 12 questions from both sections, both right triangle trig and general trig functions. Oh, let me get the right window in there. Okay, from 4.3 and 4.4, both sections that you read this weekend. So here we go. Go to joinmyquiz.com. Enter the game code 164833. Do we have time? You got 12 questions, and we've got 9 minutes now. I think so. That's reasonable. They're short. They're fast. They should be fast. Let's put it that way. Right. This is my challenge to you. Get in, get started. There's the code there on Zoom if you want to copy that. Paste. 4 people in. 5. 7, 6, halfway there. All right, those of you in, go ahead and get started. It is still open. 164833. I forgot their music is incredibly loud, but still fun. Need volume control. All right. There we have it. The first 9 are off. Natalie and Ivan with a good start. But see, I told you you could do it. As always, retake code will be posted at the end of the class days, 2:30-ish. So look for that if you will need it. And it will be open all week for you to retake as many times as you need to get the score that you so desire. Other than that, you have your exercise set posted for today. If you finish the quiz early, go ahead and start on those. That's going to do it for me. I'll leave you to work that. We'll end the YouTube stream